And welcome back, AP Calc students. Time for another FRQ. This time we are looking at the exam from the year 2016, and this is question number 2. So it is a calculator-based question, and you very quickly can surmise that this is a PVA, or position velocity acceleration, based on the given information. So let's dive in. It says, for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t is equal to 1 plus 2 sine t squared over 2. So v of t, write this down here, 1 plus 2 sine of t squared over 2. The particle is at position 2 at time 4. Now, a couple things to point out here on this one. It does say the particle is moving along the x-axis. Well, what that means is the particle is just doing this, back and forth along the x-axis, which tells us, because it's horizontal movement, you always want to remember that when it comes to position and these PVA questions, you can never hear this enough times, that when you're moving from position to acceleration, you're deriving. When you're moving from acceleration to position, you are integrating. And it's always the position that's the goofy one. Velocity is v of t, acceleration is a of t, but when it comes to position, they do not use a p. So position functions are defined typically, you're going to see if it's vertical motion, it's going to be s of t, and if it's horizontal motion, it's going to be x of t. Well, since this problem is moving along the x-axis, it means the notation for position is going to be x of t, probably most confusing of them all. So what they say here is that at position x equals 2, at time t equals 4. Well, what that really means is, if we write it this way, the position function at time is equal to 4, at time 4 is equal to 2. So you want to have that tucked away. Okay, so that's what's given, and again, because we're just on a set of axes, there's no units for distance traveled or time, so we don't do a lot of labeling on these, so it's easy to get sloppy if you later get a question that it is required. So let's see what we can do here for part A of the question. So part A says, at time t equals 4, is the particle speeding up or slowing down? Well, what this is testing you on is whether you know how to calculate speed. So when it says speeding up or down, they are directly asking you, do you know the rule? And the rule is this. We'll just review this in notes here. If the velocity at a given time and the acceleration at a given time, if velocity and acceleration have the same sign, then speed is increasing. If these have different signs, if velocity and acceleration at the given time have opposite signs, then speed is decreasing. And that's all this question is asking about. So do you know what to do, which would be find the velocity at time equals 4, find the acceleration at time equals 4, and see if they have the same sign, and then answer the question. That's what they're wanting. So first we would say, well, we might as well figure out what v of 4 is. So v of 4, according to the question, would be 1 plus 2 sine. Putting 4 in the equation would give us 16 over 2, which would be 8. So let's see what that equals. And so we use our calculator for this. Make sure you are in radians on your calculator. So we'll turn this up. We'll exit here and clear. And so we have 1 plus 2 times the sine of 8. And we get 2.979 rounded. 2.979, and in reality we don't even care what the number is, we just care whether it's positive or negative. And now we're going to compare that to the acceleration at 4. Well, before we find the acceleration, we're going to have to find the acceleration function. which means we're going to have to take a derivative, which brings us back to this here. We need acceleration. And on PVA questions, they're very predictable. It's almost always the velocity function given, you have to generate acceleration. So this one is so easy. It's such a basic function, we could do this and be good review to review our derivative rules. So before we do a of 4, let's figure out what a of t is. And let's go ahead and do this here so we can compare. So a of t, which is the derivative of velocity. Derivative of velocity is acceleration here. So derivative of 1 is 0. Derivative of 2 sine is going to be 2 cosine of t squared over 2 times the derivative of t squared over 2, which would be 2t over 2, which would just be t. So my acceleration function, when we copy this over here, is just going to be 2 times the cosine of t squared over 2 times t. And then I could evaluate that at 4. So the acceleration at 4 is going to be 2 times the cosine. 4 squared is 16 over 2. That's going to give us 8 again. And then when I'm all done with that, I'll multiply it by 4, and I'll see what I get there. Now, I could have done this on my calculator with the derivative function, but it was a nice review here for trig derivatives anyway. So we'll see if we can get the same answer. So we have 2 times the cosine of 8. And then after that's all over, we will multiply it by 4. And we're getting negative 1.164. Negative 1.164. And just to show we would get the same answer the other way, if you would have used your derivative button, number 8, you would have said d dx, and let's put in the velocity function, which is 1 plus 2 sine, and that was t squared divided by 2. And we'll close that parentheses. And we wanted to evaluate this at 4. And you can see it's the same answer if you wanted to do it that way. But now for the question, though, are we speeding up or down? Well, because we have opposite signs, our speed is decreasing. So at time t equals 4, here's what we're going to say. At time t equals 4, the particle is slowing down. We'll say it that way. Speeding down sounds funny. Is slowing down, and our reason is because the acceleration, because a of 4 and v of 4 have opposite signs. And there would be your points. 2 points there for that one. Okay. Next question, B. Find all the times in the interval 0 to 3 when the particle changes direction. Justify your answer. Well, you'll need some room to work here, so we're going to get rid of this over here. Now, since the particle is changing direction, when you want to know if a particle changes direction, that's going to be the position derivative of the position function. Changing direction, if you want to think of it this way. If you want to know if something changes direction, if this is my position function, it changes direction at peaks and valleys, and this thing is going sideways, so you could say, well, those would be kind of like peaks and valleys, but more specifically, this question is actually just going back and forth. So when does it stop and come back? Well, it's the same idea as finding peaks and valleys and having your velocity go from positive to negative or negative to positive. So we don't have the position function, which doesn't matter. We would be taking the derivative of it to get to the velocity function. So we're going to take our velocity function and see when it equals 0 or undefined to get some critical points. So we have our velocity function given, and then we can take advantage of our calculator. But just to write this here, we're going to take our velocity function, which is the derivative of position, and so we want to say, well, when is that thing undefined, and when does it equal 0 to get some critical points. And the function is, I'll go ahead and rewrite it up here so we have it to refer to. It's 1 plus 2 times the sine of t squared over 2. Well, sinusoidal is never undefined, so when does it equal 0? Well, we can just take advantage of our calculator. So when does 1 plus 2 sine of t squared over 2, when does that equal 0? So what we're going to do is we'll just go to y equals here. Let's clear these out of here. And let's see, when does 1 plus 2 sine of t squared divided by 2, that's our function. We're curious, when does that equal 0? So let's go to, we could try z-trig. So we definitely have some sinusoidal behavior there. And we're slowing down as we approach 0. And the question is, between 0 and 3 is the ones they're asking about. So let's see if we can zoom in on the picture a little bit. We'll change our window. So we wanted to go from an x minimum of 0 and an x maximum, according to the question, is 0 to 3. And I think our height was okay there, so let's zoom in a little bit more. Okay. And just to double check here, on our window, yes, we are from 0 to 3. Okay, so it looks like we only have that one spot there. And so we can go to our calculator and find what our 0 is. And we just need to get on either side of it. And so I'm just going to get a little closer here. So get on the left side of it, and then I'm going to get on the right side of it. And just enter again. And it looks like we have a 0 at 2.707. Okay, 2.707. And that is our only critical number. So, we could be really thorough here if we want. And so again, this question was 0 less than or equal to t less than or equal to 3. We only have this one spot here at 2.7. And we could actually even use this. We actually graphed the derivative to see when it equaled to 0. So you can see that it's positive in this part, and it's negative in this part. And so the derivative's changing sign from positive to negative. It's a nice part about calculator questions. And so we know that it's changing direction. So we can say for part C, or we're just on part B here. So for part B, we could say the particle changes direction at time equals 2.707 because, and here's how we have to explain our reasoning. Because velocity goes from positive to negative. Okay, my velocity is going from positive to negative at time 2.707. Okay, so when you want to justify that position is changing or direction is changing, you have to justify it with a statement about velocity changing sign. And so that's how we do it there. Okay, let's move on to part C. Part C says find the position of the particle at time equals 0. It's a little unusual. Usually you're given that, but on this one they want to know that. So the hint here is if they want position at time equals 0, we're going to use the position statement they did tell us. So if you remember, at t equals 4, we know it's 2. And so they want to know t equals 0. Well, what we're going to do then is we're going to set up a velocity integral and with the fundamental theorem get position. So what we're going to do is look at 0 to 4, and we're going to integrate the velocity. And we know that that gives us position at 4 minus position at 0. Now I'm purposely putting position just so we don't lose anybody. But because this is horizontal movement again, that's going to be x of 4 minus x of 0. Okay, now they want initial position, that's x of 0. And if you recall from early in the problem, or in the given information, they state, we'll sneak this in right here. So I want to draw a line right here. Early in the problem, they had stated that x of 4 was equal to 2. That's in the given info. So I know x of 4 is 2. I want this. So what I'm going to do is take x sub 0 and add it to the other side of the equation so it's positive, leave this here, and subtract over the integral. So what I'm going to get here is initial position is going to equal to the position at 4 minus the integral from 0 to 4 of v of t dt. That's going to give it to me. Now, again, x of 4 was given as a 2, so we could just say our initial position is equal to 2 minus the integral of 0 to 4 of v of t dt. Okay? And it's a calculator question, so we're just going to actually do that. So we'll quit out of here, and I'm going to put in 2 minus math menu, go to my integral, and I'm integrating from 0 to 4. And now I'm going to put in my velocity function that I've been using here. So 1 plus 2 sine of x squared divided by 2. Okay, I think we have everything there correctly here. And let's see what ends up happening here. We get negative 3.815. Okay, negative 3.815 is the initial position. So there's our answer. So x of 0 equals that. We've got it. Okay. Now it's time for part D. Part D says find the total distance the particle travels from time equals 0 to time equals 3. Well, here's what they're testing you on here. You want distance traveled? Well, if you want distance traveled, you have to think to yourself, do I integrate the velocity from 0 to 3? Or do I integrate the absolute value of the velocity from 0 to 3? These are two very different questions here. And so since it says total distance, it's going to be the second one. Remember, if you ever integrate just the velocity function, you are going to get displacement. But if you integrate the absolute value, you're always going to get total distance. Okay, and so the classic example is the displacement of a rocket that goes up in the air and comes back down is 0. But clearly the total distance traveled was however high it went times 2 because it came back down. Or when you run one lap around a track, if you integrate your velocity to figure out your displacement's going to be 0 because you ended where you started. However, your total distance traveled was 400 meters. So when you want to know total distance, you always integrate velocity. And usually it has something to do with a trail that backtracks a little bit. So it could be something like this, where you could see that the displacement here, just going horizontally, this distance to this distance, doesn't take into account that the trail went backwards and you ran actually quite a bit more. Or you could do that vertically. So total distance accounts for it with absolute value. Displacement does not. Okay? So we want this one. So since we want the second one, we can just use our calculator, as long as we know where the absolute value button is, and we can just get that pretty quickly. So let's see what we can do here. Let's go ahead and use that. Put that in our calculator. So we're going to use another integral, and we're going to go from 0 to 3. And then we're going to do absolute value. So we'll go over 1, grab that from the first menu on the second tab over, first entry, first tab on the second pull down. And so we have absolute value, and then we're back to the velocity function, which is 1 plus 2 sine of t squared divided by 2. And we'll just close that angle statement right there. Okay, and let's see what we get. Calculator does the work, and we get 5.301. Okay, and once again, because this is a particle movement, we don't have any labels on anything, but keep in mind if this would have been a car moving or someone jogging, whatever it is, make sure you take into account your units, whatever it is for distance and also time, and whenever acceleration was mentioned, it was your time had to be squared. So there it is, 2016 AP Calc AB number 2. All right. Thanks for watching. We'll see you guys next time.